Let's do another little brain teaser question to see if we understand our multi-loop circuits. Suppose I have two light bulbs A and B that are identical and both connected in series and to two batteries in series. Suppose also that there's a switch that connects another battery to the circuit as shown in the diagram. Initially the switch is open, so there's only current around the right-hand loop. But what happens if the switch is closed? Do the light bulbs both extinguish? Does one of them dim? Does the other dim? Does one brighten? Does the other brighten? Or does nothing change? Again, I can use Kirchhoff's second law and ask what happens in this circuit before the switch is closed. I know that by Kirchhoff's second law I have plus 12 volts plus another 12 volts minus the voltage drop through bulb A minus the voltage drop through bulb B. Those voltage drops are given by current times resistance, and because it's the same current passing through both light bulbs, it's just the same value of I. After the switch is closed, I have the two 12 volts supplied around that same loop, and I have a current passing through light bulb A and a current passing through light bulb B, but I don't necessarily know that they're the same, so I'm going to write IA-RA minus IB-RB. But after the switch is closed, I can also draw another loop clockwise through this right-hand side circuit loop right here, and I would say 12 volts minus IB-RB has to equal 0. Which tells me that since RA and RB are the same, the current through that that left-hand loop here is just 12 volts over R before, and it's 12 volts over R afterwards. And as a result, the current through bulb A is going to be 12 volts over R afterwards. So in the end, actually nothing changed. Nothing changed because for the same reason as one of our other problems that we worked. The switch is actually being closed across two places, both of 12 volts potential. If this is 0 volts down here, I've climbed up to 12 volts by this point, 24 by this point, I've dropped back down to 12 volts, I've dropped back down to 0 volts. So this point on the right-hand side of the switch and the left-hand side of the switch were both at 12 volts of potential. So the switch had nothing to do. No current would flow through the switch. Since that's counterintuitive, let's again take a look at a simulation from the Colorado Physics Education Group, which shows those two batteries, two light bulbs in series, and a third battery over here off to the side, but that's not currently active because the switch is open. Notice that both light bulbs are burning. If I close the switch, they both still continue to burn brightly, and no change in the current flow. No current flow is out here at all. In other words, the switch did nothing.